Good evening, students. Today we will learn about inductive effect. Now, what is inductive effect? Inductive effect is actually permanent displacement of sigma electrons towards or away from the saturated carbon chain. For example, if we have this chain, carbon, saturated carbon, single bonds between carbon atom. Now, if we attach chlorine on one side, so chlorine is more electronegative than carbon. So electrons are displaced towards chlorine. So chlorine acquire negative charge and carbon positive. Now, as this carbon become electron deficient, so it withdraw electron from next carbon. So it also acquire partial positive, but positive charge on this is less than this. Obviously, because this carbon is directly attached to chlorine. Clear? This carbon attached to carbon only. Clear? So next is partially positive double dash. This is first carbon directly attached to chlorine. This is second one, third. After third carbon, this effect is almost nil. Means this effect inductive effect decreases with the distance. Clear? So this chlorine has which type of effect? Electron withdrawing or releasing? Withdrawing. So electron withdrawing group has minus I effect. Means there are two types of inductive effect. First is minus I and other is plus I. Minus I means electron withdrawing effect. Clear? So chlorine has electron withdrawing effect. Clear? There are so many groups which has minus I effect, and minus I effect of chlorine is more than bromine. Bromine is more than iodine. So there is an order. Clear? First is NH3 positive. It has maximum minus I effect. Okay. Second is NO2. NO2. Then third is Cl. Then SO3H. Okay. Then we have CHO, CO. Next is COOH. Then COCl. Then COBr, COOR, then CONH2, fluorine, chlorine, bromine, iodine, OH, OR, NH2, then C6H5 and H. So this is the order of inductive effect. Minus I effect. These are the groups which has minus I effect. So minus I effect of NO2 is greater than Cn, which in turn greater than SO3H. Right? First effect. Did you understand?
Yes, sir.
Now, plus I effect. So plus I effect means electron donating or releasing effect. And this electron donating effect, or we can say releasing effect, is shown by alkyl groups. And alkyl groups, first is, hydrogen has zero effect. Then you have methyl, ethyl, then next is isopropyl, and it is increasing order. Then next is tertiary butyl. So more is the number of methyl groups, more is the plus I effect. So maximum plus I effect is of tertiary butyl. Then it is isopropyl. This is called tertiary butyl. This is isopropyl. This one is ethyl, methyl. So order of plus I effect is this. Clear? Now come to the application part. What is an acid?
Sir, which releases H plus ion.
H plus ion. Clear? For example, let us take an example of carboxylic acid. Carboxylic acid has COOH group attached to COH group attached to a group. Clear? Now, and this group mean to say either it has plus I effect or minus I effect. So now when H plus ion is removed, what would we get? CO negative. Acidic strength. Strength of an acid is directly proportional to first ease to release H plus ions. After release of H plus ion, what is left? Negative, anion. So second is
Stability of anion.
very good. Stability of anion formed. Now anion is negatively charged. So it is stable if negative charge is decreased. Because it is unstable or less stable because of this negative charge. Because it is charged, that's why it is less stable. Now if any group attached decreases negative charge, it stabilizes it. So it should be
Withdrawing group.
very good. So electron withdrawing groups increases stability of the anion, so increases strength of acid. So electron withdrawing group has which effect? Minus I or plus I?
Minus I.
Good. So minus I effect. More is the minus I effect, stronger is the acid. Second is electron releasing. So it has inverse effect. Minus I, electron releasing group has which effect?
Plus I effect.
So plus I effect. So more is the plus I effect, weaker is the acid. Right?
Yes, sir.
Now, let us take an example. Formic acid. This is
Formic acid.
formic acid and acetic acid. So tell me, which one is stronger acid?
Formic
Acid.
Very good. Because in acetic acid,
Plus
methyl has
Plus
higher
I
plus I effect.
very good. If methyl has plus I effect, that's why its acidic strength is less. So formic acid is stronger acid than acetic acid. And if we have another group like ethyl, it has more releasing effect,
Yes, sir.
so acidic strength is
No.
low. Then CH3 twice CH, still there is a decrease, and CH3 thrice C according to order. Methyl, ethyl, isopropyl, tertiary butyl. Plus I effect increases, acidic strength
Decreases.
decreases. Okay. Second example. So we have acetic acid and other is chloroacetic acid. So tell me, which one is stronger acid? Yes, chloro, very good, because chloro has minus I effect. Chloro has minus I effect. So as it is withdrawing, so acidic strength increases, and this is releasing, so acidic strength is low. Now if I increase chlorines, one more. Now
Acidic strength will
increase, because as number of chlorine atoms increases, minus I effect increases, so acidic strength increases. So second point is inductive effect increases with the increase in number of groups. Chlorine has minus I effect.
Yes.
If two chlorine atoms are there, minus I effect is more.
3 chlorine further.
Clear? So that means it is added up. Clear? As number of withdrawing group increases, minus I effect increases. Or we can say inductive effect increases with increase in number of groups. Right?
Yes, sir.
Now come to next point. Let us take an example. We have two chlorobutanoic acid. Three chlorobutanoic acid and four chlorobutanoic acid. Now, so minus I effect we can say increases it directly proportional number of groups. Now, which one is stronger acid?
Sir, 2 chlorobutanoic is cube.
Why?
Sir, because distance is
Very good. So inductive effect decreases with the distance.
okay.
We are looking at this group, withdrawing effect on this group. So chlorine is, in this case, 2-chloro, chlorine is closest to COH. In this case, chlorine is farther from COH. And in last case, chlorine is farthest. Right? So minus I effect is maximum in 2-chloro, less
In 3
In
chlorine.
3
and least in
4 chlorine.
So inductive effect decreases, so acidic strength also decreases. Minus I effect. Okay, that means inductive effect decreases
As increasing.
as distance
Increases.
from the polar group increases. Done? Another example, if we talk of basic strength. Now, basic strength. What is a base?
Which releases OH negative.
Which releases OH negative, that is RNS base. Or bronze steel dory, that
Which
which
donates
accepts
H
H plus ion.
H plus ion.
And Lewis acid,
Which
or
donates
base.
electron.
very good. Lewis base is which donate pair of electrons. So which donate pair of electron? Which has pair, first of all. Second, electron density is more,
More.
right?
Yes, sir.
Now, if we have ammonia, you know what is ammonia? NH3. So I write like this. And second is methylamine. So tell me, which one is stronger base?
Methylamine.
Good. Why?
Because of plus I effect of CH3.
Yes, because methyl has plus I effect, as it has plus I effect. So it increases the donate electron to nitrogen. So electron density on nitrogen increases. So its electron donating power increases. That's why methylamine is more basic than ammonia. Okay.
Yes, sir.
Now stability of carbocations. This is methyl carbocation. This is ethyl carbocation. Isopropyl carbocation. Tertiary butyl carbocation. So tell me, which cation is more stable?
Tertiary butyl carbocation.
Tertiary butyl carbocation, because stability of carbocation is proportional to,
Plus I.
say, these cations are actually unstable. These are reaction intermediate. They are not product in any reaction. They are reaction intermediate. They are formed in between. That means they are less stable. But if we compare stability of this carbocation, they are unstable because of charge, because of positive charge. So if any group decreases positive charge, that stabilizes it. Now positive charge is stabilized by negative, means releasing group.
Releasing group.
So that means stability of carbocation is proportional to electron releasing groups. That is plus I effect. Or inversely proportional to electron withdrawing effect. That is minus I effect. Right? Means it has one methyl group. In this case, two methyl group, three, as I said earlier, that as number of alkyl groups increases or number of any type of group increases, inductive effect increases. So inductive effect is maximum in tertiary carbocation plus I effect, because they are alkyl groups, methyl groups. In this case, two methyl group, one none. So stability order is like this. Right? Now, this is carbocation. And what is carbocation? Carbon has positive
Positive
charge.
charge.
That's why it is called carbocation. Now, let us take an example of carbanion. Now, if we have carbanion, what is carbanion?
Carbon having negative charge.
Carbon having negative charge. Now, this anion is also unstable. It is also reaction intermediate. It is unstable because of negative charge. So, any group which decreases negative charge, stabilize it. And any group which intensifies negative charge, decreases stability. Now, what about these methyl groups? What they do?
They intensify the negative.
They intensify the negative charge. That means destabilize negative charge. That means anion stability of carbanion is proportional to electron withdrawing groups minus I effect, and inversely proportional to releasing group plus I effect. Right? Means tertiary carbanion is least stable and methyl carbanion is
Most.
most. So order is just reverse of carbocation.
Carbocation.
Okay. Next is free radical. What is free radical?
Carbon having a free electron.
Very good. Carbon having a odd electron or free electron. One free electron. Odd electron. It is neutral. Now tell me, is it electron rich or electron deficient?
Deficient.
Very good. Because this carbon has now 7 electrons.
7 electrons.
It needs one more. It seems like it is electron rich because it has one free electron. It is free to donate it. But actually, carbon is electron deficient. Carbon should have
Eight.
complete octet.
Complete octet.
So if octet is not complete, it is electron deficient.
Deficient.
So it behaves as carbocation. Carbocation is also electron deficient.
Deficient.
What about carbanion?
Carbon and electron rich.
Electron rich. Because it has total 8 electrons and one unshared pair. Okay? Carbanion is electron rich. Carbocation as well as free radical. Both are electron
Deficient.
deficient. So, free radical. It is neutral having one unpaired electron, odd electron. And it is electron deficient. So, electron deficient molecule is unstable because it is electron deficient. So, which group stabilize it?
Releasing.
Releasing group, which donate electron to it. That means which one is most stable?
Tertiary butyl free radical.
The electron releasing groups stabilize it, and electron withdrawing groups
Destabilized.
destabilize it. So order is like this. Okay. This is also called primary carbocation. This is
Secondary.
free radical. Primary free radical,
Secondary.
secondary free radical, tertiary free radical, because 3 carbons are attached to free radical. Same reference is applied to carbocations. Tertiary carbocation, secondary carbocation, primary carbocation, methyl carbocation. Again anion, tertiary carbanion, secondary carbanion,
Primary carbon.
primary carbanion, methyl carbanion. Methyl is a special case. Okay? So in this way we can explain inductive effect. For more videos, subscribe to my channel, that is Suresh Thakur, and press the bell icon for future notifications, and don't forget to like, share and comment. Thank you.